Day 13 of 60 in the Go Backend Challenge. And today we kill the 200-line handler. You know the one. Open a connection, write a query, then 40 lines of rows. Next, rows, scan, append to a slice, check rows, error, close everything. Multiply that by every endpoint and your service is more scan loop than business logic. GORM fixes that. But here's the catch most tutorials skip. GORM doesn't have to steal your connection pool or hide N+1 queries. Treat it as a query builder with a schema DSL, and you keep control. Let's wire one up the right way. Start with the open. You call GORM. Open with the Postgres driver and your DSN, host, user, password, name, mode. That returns a *gorm.db. Beautiful. But that handle wraps a standard *SQL.db, and by default its pool is effectively unlimited. Under load, you'll open hundreds of connections and Postgres will start refusing them. So immediately after opening, you reach underneath, SQL.db, error, equals db.db. Now you've got the raw pool, and you tune it like you would in any production Go service. 3 settings every time. SQL.db.setMaxOpenCons, 25. Cap total connections so you never exhaust Postgres. SQL.db.setMaxIdleCons, 25. Keep them warm so you're not paying handshake cost on every request. And SQL.db.setConMaxLifetime of, say, 5 minutes. So connections recycle before a load balancer or Postgres kills them out from under you. That's the whole secret to the social media hot take. Your GORM app is leaking connections right now. It's true if you skip db.db. 1 accessor, 3 lines, and you own the pool again. Now models. A struct with tags maps straight to a table. Define user with an ID and a unique email using the tag GORM : unique index. Define order with a user ID field and a user field. That's a belongs to association. GORM infers it from the foreign key naming. To create the tables in local dev, call db.automigrate with your model pointers. Automigrate is idempotent for additive changes, new columns, new indexes, safe to run repeatedly. But run it in staging only. It will not drop columns, and it stays silent on type changes, so never trust it as your production migration tool. Let's do real service work. Creating a record is db, create, order. GORM fills in the primary key and timestamps for you. Now associations. Say you fetch 100 orders and then loop, calling db, first on each order's user. That's the N+1 trap. 1 query for the list, then 100 more, 1 per row. Your dashboard crawls and nobody notices in dev because you've got 3 rows. The fix is preload. db, preload, /user / find orders, loads every and joins their users in a second batch query. 2 queries total instead of 101. But how do you catch the N+1 before production does? Turn on GORM's logger and set it to log slow queries. Logger, new with a slow threshold of, say, 200 milliseconds. Now every query that crosses that line prints with its SQL and duration. Run your endpoint, watch the log, and that wall of repeated select from users where ID statements jumps out instantly. You don't guess at N+1s, you read them. This is the single most valuable habit when adopting an ORM. Make the generated SQL visible so the abstraction never lies to you. Next pattern, keep business logic composable with scopes. Instead of scattering db, or clauses everywhere, write functions that take and return a *gorm.db. Active orders returns a scope filtering status equals active. Overdue orders, cutoff, filters due_date before the cutoff. Then db, scopes, active orders, overdue orders, t, find, orders, chains them. Your predicates become named, reusable, and, because they're just functions over *gorm.db, testable with schema without touching a real database. Wrap them in an order repository struct and your service layer reads like English. And when GORM's generated SQL isn't good enough, a window function report, a gnarly aggregate, don't fight it. Drop to the escape hatch. db, raw with named arguments. then scan into a plain result struct. You get full SQL power and still hand back. Type Go values. Best part, you can run that raw query and your GORM model saves inside the same DB transaction, so the ORM path and the raw path commit atomically. Reaching for raw isn't admitting defeat. It's using the right tool while keeping one transaction boundary. Day 13 done. The takeaway: GORM buys you expressive models and association loading, but the engineers who run it in production always expose the *SQL.db to own their pool, log slow queries to expose n+1s, and keep DB raw ready. It's a query builder, not a magic box. Subscribe for day 14.